include 3-micron microspheres and also live cysts. The lead reduction one was a change to the test water and the water chemistry requirements to make sure that a certain percentage of the lead in that water was particulate lead, not soluble lead. So these are kind of two important changes and examples of things that task groups work on for often years at a time. And then from these standards we create a certification program. So the certification program, one of our goals is to evaluate representative products from a group of products that want to be certified. We don't necessarily test every single model. If an RO system, a company has an RO system, a family of RO systems I guess you would say, and they have the same RO element but different size storage tanks, different pre-filters and post-filters for the higher end model and the lower end model, then we will often be able to test just one of them to qualify all of them. So there's reviews that go on there. Another important aspect that Mark mentioned was inspection of the manufacturing facility. We do an initial inspection, and WQA does also, I believe, and then we do annual inspections to evaluate ongoing conformance of the products. And I'll talk about the inspections more in the next slide. Another aspect of our certification programs is that these products have to be retested every 5 years. The test data supporting the certification cannot be more than 5 years old. So for the inspections, the final assembly location is considered the manufacturing facility that's audited. So if you make systems in your garage, then your garage is going to be what we inspect. Often manufacturers will be getting carbon blocks from one manufacturer and housings from another manufacturer. Unfortunately, we can't go to those two manufacturers and audit their processes for making the housing and the carbon blocks. We hope that they are certified as component manufacturers, and so we audit them separately. So we're auditing the final production location where the system is assembled. There's two different types of audits. The initial audit, where we are going in during the initial certification process. If it's a brand new company that's never been certified to any other standards, any other ANSI or NSF standards before, we don't need to do an initial audit for every new product that is certified, just for that first certification project. And that audit is an announced audit. It's more working with the manufacturer to get them used to the process and the types of things we're going to look for when we do our annual audits. So after they achieve certification, they are subject to the annual audits, which are unannounced audits. We just show up one day and say we're here to look at, inspect all your records. We review the manufacturing process and all the materials. There's a authorized material formulation sheet that they have, and if they switch a supplier of a part without telling us, then the products could be put on hold, or a recall could be issued by NSF saying these products are not certified any longer because they switched their RO element and didn't tell us, something like that. So we review all of their records for purchasing their raw materials, purchasing their components. We review their product literature to make sure they didn't change anything on us. They changed the 90% reduction for nitrate to 95% reduction because they ran a test at a different laboratory and they got a better result. Well, they didn't get that result with NSF or with WQA, so they can't claim 95%. They have to claim 90, let's say. And then any issues that we find are put together in a corrective action report that an auditor issues, and then the company has to follow up with project managers at NSF or at WQA to resolve these issues and work through these issues. And then if it's a significant, as I mentioned earlier, if it's a significant enough issue, we could put product on hold and not allow them to ship the product until this issue is resolved. So that's just a quick overview of the standards process, the administration of the standards, and also a little bit about the non-testing components of the certification program. And now I will hand it off. I guess, should I stop for questions or should I just keep going?
go ahead and take a couple.
Okay.
Any questions? Sorry. Any questions? Oh, there's one on the web. Okay. Let me read it. Do single home water treatment units have to be NSF, ANSI approved to be sold to consumers? If not, how do individual consumers know such a certification program even exists?
Well, in California, I believe it's based on whether they have a health claim, correct?
Right. This is Mark Burns. I can answer that for California. If there's a health claim made, the device has to be certified by the state of California to make that health claim in California. Obviously, with internet sales, things are being sold everywhere, and it's getting harder and harder to police. So our certification in California is in addition to and looks at some things beyond what they do with their process, but we rely on them to take it to this level. Then we focus a lot on literature review and verifying some of the data for California-specific standards.
Okay. And unfortunately, as far as other states are concerned, there's only 2 other states, Iowa and Wisconsin, that have their own state certification programs. In any other state, there's no policing of what is sold in a Home Depot or a hardware store in those states.
Thank you, Mike.
Okay, thank you. With that, I will hand it over to Amanda from WQA.
All right, good morning. My name is Amanda Fisher. I am the Product Certification Manager with the Water Quality Association. Mike, he just went over the standard development process with us, how the NSF standards are created. As was already stated, there's several different certification organizations that can test to those NSF standards, NSF obviously being one of them, and my organization, Water Quality Association, is one of the other ANSI accredited certifiers. Mike did give us a basic overview of the certification process, the auditing requirements. What I wanted to do was go over the testing and literature requirements that are in the standards that cover point-of-use nitrate removal products. All right, so there's 2 standards that I'm going to be talking about. The first one is NSF ANSI 53, which is a standard that covers drinking water treatment units' health effects. It's basically filters that are making health-related reduction claims that fall under that standard. So if you had some sort of ion exchange-based nitrate removal system, it would fall under this standard. To be honest, we currently don't have any point-of-use ion exchange-based nitrate removal system certified, but nitrate removal is covered under this standard, so I was going to talk about it. The other standard is NSF ANSI 58. That is the standard that covers reverse osmosis systems. Both of these standards have 3 main testing requirements. That's extraction testing, structural testing, and performance testing. And I'm going to go over all 3 of those. The first test that I'm going to talk about is extraction testing, which is basically where we look at all of the materials that come in contact with drinking water and evaluate them to make sure that they're not leaching anything harmful into water. So Mike was talking about how we get a wetted parts list for the materials. What we do is we have our toxicologist review that wetted parts list and come up with a test battery that's based upon that wetted parts list. So depending on the materials that are in contact with water, it'll determine the test program that we run on the product. Also, I wanted to say that systems that have some sort of adsorptive or absorptive media, they're tested both with and without the media. So a typical RO system has a pre-filter and a post-filter, maybe a carbon-based filter on it. We're going to test that system for extraction both with the media in it and without that carbon media in it. And that's because the carbon media is known to remove contaminants from water. So it's very possible that as part of the testing, if the carbon's there, it's actually going to remove those contaminants that we're looking for. We also have to test it with the media, though, because the carbon also can add contaminants into water, so we have to do both of those tests. So the exposure protocol is pretty much the same between the 2 standards. We're going to install the system on a test bench, and then we're going to flush and condition with exposure water. So when we flush and condition the system, we're basically following the manufacturer's instructions. If your manual says to rinse the product with 10 liters of water prior to use, that's what we're going to do. We're then going to close the outlet and maintain the system with water in it for 24 hours. We're then going to take 2 liters of water. We're going to throw out the rest. We're going to fill it again. We're going to maintain it another 24 hours, take 2 liters, dump it, do it another 24 hours. Basically, the test is 3 days long, where each day you're selecting 2 liters of water. And at the end, you're combining all those waters into 1 6-liter sample. So it's, like I said, it's a 3-day test, and it's a combination of what's extracting out of it over those 3 days that we're analyzing. And that water gets analyzed according to that test battery that I talked about in an earlier slide that our toxicologist came up with based on the wetted materials. I have a slide here just showing the extraction exposure water that we use for 53 versus 58. The only noteworthy thing here is that you'll see that for 58 there's no chlorine in the water that we use for testing, and that's because typically you do have a pre-filter on ROs that removes chlorine from the water, so you're not going to really, like, membranes don't normally see chlorine. They degrade with chlorine. So we do the testing, we follow the test program that our toxicologist came up with, and we get some results. And we compare those results against the maximum contaminant concentration, or the maximum drinking water level, which are basically EPA levels, Health Canada levels. If there's not a level, we may already have a clearance level for that compound, but if a level doesn't exist for something that extracted out of that product into water, we can maybe establish a clearance level by following requirements that are in the standard. So the standard does give some criteria on how to establish a pass-fail level, but this can add weeks sometimes onto a project after you get test results back, because that toxicologist is going to have to go and research all of the literature out there on that chemical to determine if it's toxicologically significant, if a level can be established, if that level can be established high enough that you need it at for what it's extracting out of your product. And then sometimes we have unknowns that extract as well. It's something that comes up. Maybe all we know is that it's an unknown oxygenated compound, and we don't have any additional information. We may need to work with the manufacturer to try to identify what that unknown is, or if we can't identify it, maybe just look at the class of compound and see if we think that it's going to be an issue toxicologically. All right, so that's extraction testing. I'm going to move on to structural testing. This is testing done to avoid home damage through leaks caused by pressure spikes in the system. There's just 2 types of structural testing that's done now. It's hydrostatic testing and cycle testing. Hydrostatic testing holds the system at a designated pressure for 15 minutes, and that pressure depends on the specific system that we're evaluating. So some systems get tested at 1.5 times the max working pressure, or 150 psi, the higher value of the two. Same thing, some systems get tested to 3 times the max working pressure, or 300 psi, again, whichever is higher. And then there's actually some systems that don't get any hydrostatic testing at all. Imagine your pitcher system that you use, you fill up at your faucet, that's not ever under pressure, so there's really no reason to do a hydrostatic test on it. There are reasons why certain products are tested at 1.5 times and some are tested at 3 times. As an example, the faucet-attached RO system is a system that really is only seeing pressure when you turn your faucet on. So it doesn't need to meet as high of the pressure requirements as a system that's not faucet-attached, for example. The other type of testing we do is cycle testing, where we cycle pressure through the system. The amount of cycles depend on the type of system, again, just like the hydrostatic testing. So there's some systems that don't have any cycle testing at all. Pumped RO systems don't need cycle testing. Portable filter systems in general don't have any cycle testing. So again, your pitcher system. Some other systems get 10,000 cycles from 0 to 150 psi, while others get 100,000 cycles from 0 to 150 psi. Again, I can use the RO faucet attached system as an example. It's not seeing pressure as often as a system that's hooked up to the line and always seeing pressure, so it just has lower pressure requirements. Okay, the final testing is performance testing requirements. So this is testing that's done to confirm the system performs as it's expected to perform. So for NSF ANSI 53, that filter-based standard, there's several tests that are just required tests. in the standard, and one of those is a performance indication device verification test. So if your product comes with some sort of device that tells you when it's reached its capacity, when it's time to change your filter, we're going to do a test to make sure that it actually goes off at the right time. That if you have a 1,000-gallon capacity, we're making sure it goes off right around 1,000 gallons. I think it's actually negative 20% to plus 10%. So it could be anywhere from 800 to 1,100 gallons that this light, this alarm, whatever it is, goes off. We also do a minimum service flow test at 30 psi. The standard specifies certain minimum flow rates you have to meet. We do a rated service flow test at 60 psi to make sure that the flow rate you're claiming is actually the flow rate that we're getting in testing. And then under 53, there's also performance claim verification, which is optional, but you have to have at least one performance claim to be certified under the standard. So there's lots of different claims, you know, lead, arsenic, nitrate. You just have to have one to be certified under 53. Right, under 58, similarly, there's performance testing requirements. Some of these just depend on the specific system that you have. So if your system has a storage tank, we do a storage tank capacity test to make sure that whatever you claim that that tank holds is what it actually holds. There's also performance indication requirements. This is not a test. This is just something that is a basic requirement for an RO system. So it basically depends on the claims you're making, but I wanted to specifically touch on nitrate and nitrite. For nitrate and nitrite, you have to either have a monitor on the product water stream, or you have to have some sort of sampling kit that comes with the product with a recommended frequency of analysis. And that's because with ROs, there's no capacity, so it's hard to determine when it's time to change the membrane. So the standard requires that you somehow include something with the RO that tells people when to change it. All ROs have to go through TDS reduction testing. They're challenged at 750 milligrams per liter, and they have to reduce 75%. If you're making recovery efficiency rating claims, we verify those. We also verify that the daily production rate you're claiming is in fact the daily production rate that your system makes. And then similar to 53, we're doing performance claim verification. So if you say you remove lead and arsenic and nitrate and cadmium from water, we're actually doing testing to confirm that the product removes those things from water. All right, so to touch more on the performance claim verification, 53 and 58 include many optional contaminant reduction claims. Some of those are chemical reduction claims, so organics, VOCs, inorganics, radon. And then others are mechanical reduction claims, so such as asbestos, cyst, turbidity. Both of those standards have both of these in them. So because this is a nitrate conference, I just wanted to touch specifically on the nitrate testing in these particular standards. If you're testing for nitrate-nitrite reduction, which is done together always in NSF 53, we're going to test the filter with a 50% on, 50% off cycle for 16 hours. And each cycle is 15 to 40 minutes. So if we test the system for 30 minutes on, we're going to then let it sit for 30 minutes. And then again, 30 minutes on, 30 minutes off. So out of those 16 hours each day, the system's actually only running for 8 hours. Then after those 16 hours, the system rests for 8 hours under pressure, which is basically overnight, right? The non-working day. And then we start up again the next day. The manufacturer does have the option of doing a 10% on, 90% off cycle. The problem with doing this, well, the good thing about doing this is you're more likely to pass. When the system's being challenged less frequently, you tend to have more favorable results. The downside of this is that the test takes a lot longer to reach capacity, so the test is more expensive and is more time consuming. So most of the time people opt for the 50-50 cycle. Systems that have a performance indication device are only tested to 120% of the capacity, whereas systems without a performance indication device are tested to 200% of capacity. So this is where it's a little bit more favorable if you have a performance indication device. There's sort of a safety factor built in because you don't know if the consumer is actually going to change their filter when they're supposed to change their filter. So if they don't have a PID, we're testing it out to 200% of the capacity just to be safe. For 53, I've put the specific test water that's used up here. The reduction requirements, again, we're challenging nitrate and nitrite at the same time. The influent is 30 milligrams per liter. It's 27 milligrams per liter nitrate and 3 milligrams per liter nitrite. This is as nitrogen. So I think that corresponds to about 120 milligrams per liter nitrate and 10 milligrams per nitrite, not as nitrogen. And then the maximum effluent concentration is 10 milligrams per liter. And no more than 1 milligram per liter of that 10 can be nitrite. Every single sample point from the previous slide, all of these 0, 25, 50, 75, 100, 120, all of those need to meet that 10 milligram per liter concentration. If one's over, it's considered a failure, so every single one needs to meet that. All right, so I'm moving on to RO testing, which is a little bit different than the filter testing. For ROs, like 53, we're testing 2 systems, and we're conditioning them to the manufacturer's instructions before we start the test. We're going to remove any pre and post filter that's on the system, because under 58, it's the membrane that's holding the claim, not the filters. And then we're going to test it at one of 2 different pressures, either 30 or 50 psi. Systems that are recommended for a minimum influent water system pressure between 20 and 40 are tested at 30. Whereas those that are recommended for a minimum influent water system pressure of 40 are tested at 50 psi. So this here is basically the test program that we're using. The sampling I'm showing here is based upon a system with a storage tank and automatic shutoff valve. It is different, but only slightly different for systems that don't have storage tanks or automatic shutoff valves. The difference you'll notice here between the filter test and the RO test is that the RO test is always 7 days, no matter what. It's a 7-day test. There's no capacity on an RO, so we're not testing it out to capacity. The test program is trying to mimic different types of use patterns. So on day 1, you're sampling at 4 hours, you're completely emptying the storage tank, you're letting it refill, you're sampling at 12 hours and completely emptying the tank. So that's sort of representative of what happens when you're taking all the water from the storage tank. Days 2 through 4, though, you're only taking 5% of the daily production rate every 6 hours. So this is more typical of what you're using day to day in your household. You're turning your faucet on, you're turning it off, you're turning it on, you're turning it off. You're only taking a small percentage of it. So days 2 through 4 sort of represent that smaller portion that you're taking from the tank. Days 5 through 6 are a stagnation period. I would say this kind of represents that weekend that you go and you're on vacation. You're not at home. And then day 7, you're sampling right after that stagnation period, and then again 4 hours later. So typically with RO membranes, you're going to have contaminants creeping across the membrane when the membrane's just sitting there and it's stagnating. So what's typical is actually to see higher contamination after this stagnation period. You're probably going to have higher results in the water. So that's why we try to test it in different ways so that we can see the different contaminant levels. It's a total of 16 samples that we get. I have the test water up here. You'll see that the turbidity through chlorine is just what we start with, and then we actually add sodium chloride to it to add TDS. So the nitrate gets challenged along with TDS, and we can actually do the TDS reduction test with the nitrate test at the same time. The reduction requirements are exactly the same between 53 and 58, except that only 90% of the individual samples have to be less than the 10 milligram per liter level. What that effectively means is you could have one sample point that's above 10. Unlike the filter standard where all of them have to be beneath 10, you can potentially have one that's above 10 here. So that's the end of the testing requirements. I just wanted to briefly touch on the literature requirements that are in 53 and 58. After your testing's done, you're ready to certify your product, but before that, we do have to review the literature to make sure you're not making any claims that aren't accurate. So manufacturers are required to provide their manual, their product data sheet, their data plate or label, any replacement component literature and packaging, and also product packaging when it's applicable. We're reviewing all of that, and we're making sure that the claims you're making match the test data, that you're not making claims that are above and beyond the data, that you're not claiming something's certified, that we tested it and we didn't test it. And then I finally just wanted to touch on specifically the nitrate and nitrite only. For the performance data sheet, the filters in RO systems, the performance values just must match the test results. I was saying that's for any claim. But specifically for ROs that are tested at 30 psi, you have to make a statement in your literature that the system is acceptable for treatment of influent concentrations of no more than 27 milligrams per liter nitrate and 3 milligrams per liter nitrite in combination measured as nitrogen, and is certified for nitrate reduction only for water supplies with a pressure of 20 psi or greater. If it's tested at 50, it's 40 psi or greater. So this kind of goes back to what Mike's saying. Here we're telling you that you can't use it when the concentration of nitrite is above the 30 milligrams per liter, that 27 and 3. So these systems aren't tested for really high concentrations of nitrate. So that's everything I have on testing and literature requirements under 53 and 58 for nitrate removal. Does anybody have any questions?
We've got a couple.
Hi, this is Carl Carlucci with CDPH, and I'm wondering about the PID type of device for the RO. Are they EC based, or what are they? Because with our point of use regulation, you know, we do require some kind of an indicator,
Right.
and I'm just wondering, is it based on EC?
The requirement says that it can be some sort of online type analyzer, though I think that's traditionally not something that manufacturers are able to do. I think you're usually seeing test strips or something along those lines. Are you seeing anything different?
Yeah, test strips there are. I believe there are. Can everybody? Is it on? Okay, there. Sorry. I believe there are a couple systems that would have, like you said, an online TDS monitor where they're actually measuring the TDS in the water.
But not the
Some sort of
nitrate itself.
electrochemical, yeah, but not. I'm sorry, yeah, not for nitrate. So, yeah, for the nitrate claim, I guess they have to have a specific way to measure the nitrate. So, I don't know if the technology exists for online.
Well, because the online nitrate analyzers are 10,000 plus, so it's
Yeah.
not going to be
Right.
that.
Yeah, they give you the option in the standard to do that, but I don't think I've seen a manufacturer do that because it's cost prohibitive. So usually it's like a test strip type of thing.
Okay.
Yeah, thank you. Paul Boyer from Self-Help Enterprise. A little bit off subject, but another community we're working with has uranium, and they actually are using like a GE point-of-use device in some of the houses. But when we're looking for certifications, we never found any certification for uranium. And I'm wondering if there is one, or if there's a lead or some other element that you could go by to see if they would work for uranium.
You said radium or uranium?
Uranium.
Oh. Yeah, I don't think we have anything that covers uranium.
I don't. Though uranium is not included in 53 or 58 as a claim. It may be that, we have a radium reduction claim, or it may be that the lead claim, could be a surrogate, but it's an issue of, how often, what's the demand from the manufacturer to have a uranium claim? How often is it an issue? And, it's an issue of doing that, like I mentioned, the task group work and putting together the task group to do a method validation study to determine that something else could be a surrogate for uranium.
Right, we couldn't just make the assumption. There would have to be the full evaluation. It would have to go to the joint committee. It would actually have to be put into the standard before we could do any certification based on that.
Any other questions? Hang on.
Friends 5U Ever State Water Board. You mentioned that you were adding sodium chloride salt. And it was. Is that a factor that there are some areas where salt, additional salt load is limited, or there are rules around adding salt to a system? How do you deal with that?
It's just representative of TDS for a system. So that's what we use when we do the TDS reduction testing to prove that the system removes total dissolved solids, which is what ROs are typically known for doing. So I think I'm not sure why specifically the nitrate water needs it, but I'm guessing it's because typically there is some sort of total dissolved solids in the water, and you're trying to mimic the real field use. Does that answer the question? Okay.
Other questions in the room?
Carl Longley, Central Valley Regional Board, but in my other role with the university. I have seen a number of facilities that have a uranium requirement or have uranium in their water. I think that a survey or something to determine a need would be certainly beneficial before you made a decision, obviously, to launch into a full-fledged certification process. But I have to back Paul up. There is that need out there. I don't know how wide it is, but I do run across it from time to time. So I don't want it to fall off the table. I think it needs to stay on the table.
Thank you. And another issue with uranium is, is it something that's safe to work with in the laboratory for testing purposes? And we often have to evaluate that also. Can you create a test water and put uranium in it easily? Is it difficult to get it into solution? Can you obtain it in a reagent grade or something like that to put into a test water? All these are issues that have to go into any development of any new test method also.
Just a comment, Cindy Forbes with Department of Public Health. We have uranium-laced water if you need some. We have a lot of systems that we can get that to you, and we can find you radon, and we can get you almost any kind of constituent you are concerned about. We can find water that has that. A comment on what will remove uranium, kind of anecdotally. We have a number of systems where they have installed ion exchange units under the sinks, and uranium is removed. It does open Pandora's box as to what do you do with the cartridges that are now considered a low-level radioactive waste. But so Paul, if you need to, we can help you below the radar, so to speak. Thanks.
This is Mark Bartson with CDPH. I would like to clarify on performance indicating devices. They are almost always a volumetric device that measures how many gallons and a light or an alarm goes off, as opposed to something that actually measures the TDS or the nitrate level. So just to clarify, by performance, it's almost always a volumetric. Did you have any comment on that, Amanda?
Well, for filters, yeah, it's almost always volumetric, but for an RO system, because there's no capacity, it's not really a volumetric-based thing. So it can be just some sort of test strip that comes with the system. Even, I think, one of the things for TDS, because there's requirements for TDS, is if the system just stops functioning, that's considered a performance indication device.
So I know some of the devices now have an optional TDS monitor, and would that be something that you guys would check the performance of then? Is there a standard to check that performance? Do you know offhand?
Actually, no, I think the requirement is it just needs to be equipped with some sort of indicator. We don't actually check it to make sure. It's a 7-day test, so we don't run it out beyond to make sure it's still functioning correctly. So the requirement is just that there has to be something there, or at least a warning in the literature when it comes to TDS that there's a certain time frame at which you need to test it and make sure that it's still functioning properly.
Thanks. And one other question for Mike on the possibility of going to a higher standard or a higher level test water for nitrate. What other concerns would come with if you had a water with 200 milligrams per liter of nitrate, the co-contaminants? Is that part of the discussion in your initial committee work on that, or the group that's meeting on that?
No, probably it would just be nitrate only. That would be the concern of that group. Yeah.
Thank you.
Other questions in the audience?
The problem is multiple contaminants. It's not just nitrate. Now, we're talking about nitrate today, and so where does this go? I mean, are you going to chart a path for multiple contaminants? Are you just not going to go there because it's just
Well, they all get tested separately. So it's just that there's not a single challenge necessarily. The products get rated for removal of multiple things. They just aren't necessarily looking at what happens when nitrate also has lead in it. Does it affect the nitrate removal? That's not something that's been looked at, but we do evaluate the products for many different reduction requirements.
Eugene with Department of Public Health. I think part of that for any system that's want to try to use point-of-use devices, the first step is actually to get a device pilot tested at the specific water, because the performance is definitely system specific, source water specific. So, and also apply pressure too. I think on the story that we'll hear soon, it's like if the feed pressure is lower at a particular home due to old plumbing, the system won't perform very well. The system generally performs much better when your feed pressure is higher because you have more clean water coming through and more of the solute stays behind. So that's definitely a problem. So for the certifiers for WQA and NSF, they're able to at least distinctly for each contaminant to see how well it works. And then the real life, before we can roll it out to people's home, is the pilot testing. That's why it's critical.
Any more questions? Okay, time for a break. If you could all be back here at 11:15, so 15 minutes. Thank you.